So again, I'm Dorothy Stewart, and this is
Jake
Jake Farrell.
Yeah.
And we're going to demonstrate the Slinky Wave Lab. And so the objective here is a demonstration of all the parts of the wave that you have taught in your classroom. So students will probably be on the floor. That's the best place to put them because of the length that the directions tell them to stretch their slinky. I also want to be a little bit careful about how far they pull it and not to extend it too much, because then the slinky does not go back into place. I was just thinking about that. So they're going to demonstrate the transverse wave and its parts, and the longitudinal wave and its parts. And so as the students stretch it out, let's say they're doing transverse wave, they'll have a partner on one end, and students manipulate this in more than one way in my classroom in the past. Some of them will go left to right with their hands to show the crest and the trough, and then I've had other students to take it and they'll go in the air. And when this is a little bit longer, that you'll see this happening, and then you'll see
it where it has the
it
crest.
happening. And so it just depends on how the students want to demonstrate it. Either way is okay. And so in the rest position, they can just be thinking of rest position as the floor, or they could be thinking of it as an imaginary line that's below when they're doing that. Again, you're going to make sure that they demonstrate, and I had my students to show me, even though they were talking among themselves first, and they were writing on their response sheets, then I went and I said, okay, show me amplitude, manipulate it, freeze it if they could, show me the parts.
Yeah.
And so amplitude, the rest position, the crest, and the wavelength and trough need to be demonstrated.
Yes.
Okay?
And in this lab, there's some really good questions that talk about, manipulating and everything like that, and we'll demonstrate just a little bit of that here in just a moment. Now, like what he said, we're doing it in such a small area that you can't really see that full manipulation. Whereas if they're doing this over the 4 meters that they would have this normally stretched out, you'd be able to see this pretty easily. Also, a really good way to incorporate technology is by having them record this and then explain this on their video and pointing out the parts. If they're working in groups of 3, having one student say, okay, this part right here is our crest, here's our trough, and so forth. And so we'll just demonstrate the 2 waves real quick. So here we'll start off with our transverse wave. So our transverse wave, we're gonna go like this. Now in the directions it talks about increasing the frequency. Well, increase the frequency, you basically you have to increase the speed at which you're moving your hand. So we'll increase the frequency real quick. And actually, as we increase the frequency, you can almost see the full wavelength now. And so that's actually, it's going to ask in the lab, it's going to ask what happens to the wavelength as you increase the frequency, and so that wavelength gets shorter. The other wave that I asked you to demonstrate is a longitudinal wave. And so to do a longitudinal wave, all you do is jerk it back and forth like that.
And along the way, sometimes I've come to the students during my teaching sessions and not in the lab, and I've stopped it, and I've asked them, well, what do you call this part? Because by that time you would have already shown them what it should sort of look like, and so what is this part called? And then what do you call the other parts, and what they're distinguishing the different parts of the longitudinal wave. So they can either do the refractions, or they can say, okay, this is the parts, that's the compressions. And that's just for my knowledge's sake, and so I want to hear them verbally say it as well.
And also with the longitudinal wave, you can also manipulate the amplitude of longitudinal wave. You don't label the amplitude on a longitudinal wave, but you can still manipulate it. So here's a small amplitude with longitudinal wave, whereas this is a large amplitude with longitudinal wave. And you can ask the students to demonstrate that without you giving them that direction, saying how would you manipulate the amplitude of a longitudinal wave, and just have them start thinking through that. Or how would you manipulate the frequency of a longitudinal wave, and once again, it's all about that vibration rate.
And so the lab is meant to have them think on a different level instead of saying, here's a question, and it's just a totally different one script answer, but they have to actually talk among themselves, get a discussion going, and you got things where they're actually like telling relationships between what they're doing and what they're looking for and what they actually see.
Yeah.
Okay.
And overall, the biggest thing with the waves is that the students need to understand is that the wave is the transfer of energy. Ultimately, whenever we're done with the wave, after it's done moving, it's returned back to its resting position. The only thing that has changed is not the position of the actual springs or the coils themselves. Only energy was transferred through that wave. The matter, the material, the medium all remained in the same position. Even though it moved temporarily, it moved back to its original spot. Is that everything?
That's it?
Yeah.